okay? And so I'm pleased that you even asked. Some students will just accept what the professor places on the board and not really think about what's going on, but he asked, the professor, is there a formula out there? Sure enough, Mr. Park found it for us, and that was a formula that we give in terms of the Fibonacci. Now, what I need to do, and what I did after I got home, I thought, hold on, I did so much yesterday. I mean, I did a lot yesterday. You did a lot yesterday. So I thought, oh wow, I better, before I jump into the review for the final, which I'll do, I had better slow down and do a recap. Where's Caroline? Caroline, you asked a question in the 2 o'clock session, which I'm going to address here. So students are still concerned about this chapter 11. It's all new. Some of this may be new for all of us. I don't know. Some students may have seen this back in high school, a little bit, on the sigmas and the summations, because it's just crazy. And chapter 11 is crazy. Yesterday was crazy. So I thought, hold on, I better do a recap. So guys, I'm going to do just a little bit here in this chapter 11 to close it down all the way. And I'm going to start out with this. Let's call it a recap. And sort of tie things together because I need to say a few things about chapter 9 in the course over. A at time in chapter 11, A will identify a sequence that might look like this. A subscript n is equal to, I created this one. Back to textbook, may have that one. And they ask you to find, say, the first 5 terms of that sequence. Let's see if I have everything I need here, guys. Hold on. Oh yeah. First term is -2. I need that. So they gave me the first term, and then they gave me like a formula. Now that's the best. That's the best case you can see on the final, where they gave you the formula, along with maybe the first term to get you started here. And they're asking here to find the first 5 terms. Now that A subscript 1 means the first term is -2. So that means if they want the first 5 terms, I'm missing 4 terms. Now what are those terms going to be? Thank goodness they gave the formula to me. But now I brought this in because we need to translate what that formula means. Guys, my second term, I'm going to call this A subscript 2. Let n be 2. If I follow the formula, it says this should be 2 plus A subscript 2 minus 1. Back to my given, and replace n by 2. Look for the second term. Clean this up. This is A subscript 2 is equal to 2 plus A subscript 1. Thank goodness they gave A subscript 1 to me. So I now complete this and write this as 2 plus a -2. Put that in parentheses there. That was given to me. And after all that thought, the second term has a value of 0. So if that formula is given to me, just be careful with it. I think it's much better than you trying to guess at what maybe those terms might be. Okay, let's try the third term. If you see, because I'm on top of the board, if you see a mistake, let me know. Third term, A subscript 3. If I follow the formula given up there, A subscript 3 is 3 plus A subscript 3 subtract 1, or 3 plus A subscript 2. Now A subscript 2, if we're correct, we had a 0 earlier. So if I do that, it looks like I'm going to end up with a 3 and see if you guys will agree. Next term, A subscript 4, just be patient. If I follow the formula, it says n is 4 in this case, plus A subscript 4 subtract 1. So we end up with 4 plus A subscript 3. And A subscript 3, we just discovered was a 3. If all that's correct, I'm going to end up with a 7. last term. Last term, I guess 1, 2, 3, 4, 5, the fifth term. If I do it correctly here, my formula is 5 plus a subscript 5 subtract 1. That's going to be 5 plus a subscript 4. And looks like that was a 7 earlier. If I do all that, I think I get a 12. Did anyone actually finish it up? Did you get those numbers I have? Same numbers? So guys, that's the best you can see on the final exam. If the formula is given to you, and by the way, they give a name to this, they call it a recursive method. Just in case, you ever see that word recursive? It actually means to repeat. So what we're doing is repeating values to find the next value. Now, is there a risk here? Yeah, the risk is if I miss this one for I made a simple mistake and I did not get a 3, I got a 5, then that's going to throw the others off. So there is a risk there. But you do what you got to do. That's one thing I thought about. Another thing I thought about was part 2, just in case. I'm going to do this. Let's call this part B. And given, just in case the terms are listed like this, no formula. I brought in this. Let's make it infinite. Looks like that, and you're trying to come up with, find a formula. I'm just list it like this, find a subscript n, in other words, a formula. And this time the formula is completely missing. And you got to come up with a formula on your own. This one's interesting. Guys, you can write it recursively. If you are clever and you say, Professor, can I write like this one? This one was given to me. Go for it. Or can I come up with just a standard, looking at it, a standard formula that when you start replacing n by 1, n by 2, n by 3, you get those numbers. For about
I got it.
Another student's got it. As soon as I see that smile on that face, I know he's got it. Now, Jonathan, first, did you just get a straightforward formula?
It's kind of, I go with exponents, but it never.
It's got exponents in it? Okay, what is it? We'll test it.
I haven't really tested it yet, but n to the power of -1 to the power of n minus 1.
Oh, all this raised to another power?
The -1, I want to raise that, or multiply that times n minus 1. I think,
Wait, so let's calm it down a little.
yeah, so n to the power of -1 times n minus 1.
Over here on this side.
But for the -1.
Whoa. What you are thinking about here.
Like it,
Mr. Park, bring that eraser over for me, would you?
Sure.
You're talking about n minus 1 up here.
Yeah.
Wow.
So I'm trying to create a negative exponent.
Okay, first tell me, that's what you have in mind.
Yes.
I'm going to test it. The first term, the first term would be, well, you said n is 1 in this case, right? 1 raised to a -1, raised to 1 minus 1. I think it's what you can do, right?
Something like that. That may not work.
Well, I see this will be on the outside as a 0, and anything raised to the 0
Yeah.
power is 1. That'll be the first term.
Yeah.
Because this is on the outside 0.
It starts to increase. I was just trying to create a -1 and then +1, -1, +1 as the
Yeah,
exponent.
but you know what? You may have some here. You try the second term. Now your formula. I replace n by 2. That's what I do here. Raised to a -1. And on the outside here would be what? 2 minus 1 is 1? Like that? And guess what? Is that 1/2? Is 2 raised to a -1 1/2?
Yeah.
So far, so good.
So far.
Third term. He wants me to replace n by 3 here. raised to a negative 1 he wants. On the outside, n minus 1 would be what, 3 minus 1? Now this one, let me throw us. This is 1/3, right? Make sure I put everything in correctly. On the outside, I have what, a 2? That says what, 1/3 squared? If I did it correctly by your formula. And that would give me a 1/9. And we want a 3. Work for the first 2 terms. I'm glad you brought that in because sometimes you'll check it just for the first couple of terms and say, oh, it always works. No, it didn't work for the 3rd term.
Can I give the power of power?
Okay, begin.
Give the power of power.
You mean keep what he has?
Yeah. No, then I give the minus 1 to the power n minus 1.
Yeah, that's what I was.
Wait, hold on now. Okay. You want me to keep n here?
Yeah.
Okay.
To the power minus 1, and then minus 1 power n minus 1.
So the minus 1 has a power itself.
Oh,
So-
up
so the
here.
power, yeah, there you go.
You stack them.
N minus 1.
N minus 1. You stack them up like that?
Yes, that's how I wrote it down.
Good Lord. That's what you mean?
That's what I meant. You got it, and that's right.
Mr. Parker, Marina, I've taught both you guys. I don't think I have ever seen someone give me a formula like that before. I don't think. They're saying it may work, right? John?
It does.
Okay, let's try it. I want you to jump around. Let's try 1, 2, 3, 4. Let's try the 4th term, which should be 1/4. So A subscript 4, if this is correct. You're saying it's 4 raised to a negative 1, and that's being raised to the 4 minus 1. So this is 4 raised to, are you telling me this right here is like negative 1 cubed?
Yes,
Okay, and negative 1 cubed, of course, is negative 1. Look at that.
there it is.
I'm being very honest, I'm experiencing some input from students that I have not witnessed in a long time. I know when I had these 2 in class, they were great too. Those classes were great. But I am hearing things now, wow. That's not quite what I had in mind when I saw it, but that formula looks like it's working. Jonathan, that's what you had in mind, right? Strange, but it looks like it's working.
There seems to be like a common pattern to like get -1, it's n minus 1 or n plus 1. And so,
Always an n minus 1 or an n
and
plus
so I
1.
was trying to like get a -1 on top,
Okay.
and that was
Okay.
the idea.
Okay, gotcha. Did someone have something else in mind? I'll show you what I had in mind. It's a little bit, this is complicated. I love what you guys gave me. Looks like it's working. Wouldn't it be interesting to try to prove this always works? By deduction. Oh, that would be a fun proof. But I mean, definitely not going to do something like that. Guys, on the side here, I'm gonna write mine like this. A subscript n, think about another formula when I first saw these. They're gonna help me out though, I may mess up here. I notice these numbers are odd. And then the other remaining numbers, I don't know whether this will help or not. I gave you what? 1 over 2, 1 over 4, 1 over 6. I notice these denominators are even. Maybe I can split it up into 2 parts and say A subscript n is equal to, and have 2 parts. Try to get the odds out of the way with something going on, and those even 1/2, 1/4, 1/6 with that denominator, and split it up into 2 parts. Now I was just looking at it quickly. I don't think I wrote the formula down. First one was this. Now look at this, how strange. It's merely n if n is odd. So guys, I'm saying first term, since 1 is odd, it is 1. This is my third term, shouldn't just really be 3, it's odd. This is my 5th term, which is an odd number, just 5, if it's odd. Then I notice, like I said when I was looking at all the terms here, I wrote the next part as it's this, if n is even. Would that now fill in the others? I was thinking about that. Jonathan,
Yeah.
you guys who gave you this, I was not thinking about this. This is huge. And it works. I was thinking about something like that to get the terms. Okay? So guys, when I score these papers, when you take the exam on Friday, and if I do have something with a list of numbers and I should come up with a formula, I guarantee you I'm going to slow down and say, hold on, does this really work? It may not be the same one I have on my key. I gotta look back and see if it checks and works. Like we're checking papers. Jonathan, I might say, look at that and say, what? I may, have this. I was looking for this, you give me this. Look how different they look. All of a sudden, they're the same. Or they give you the same outcome on that. So guys, watch out for something if you see something like that. And part C, in my recap, let me put it up here. Here's what we're really concerned about, I think. I said, Professor, how will you quiz us, test us on the binomial theorem? And I brought this in. I have 3x plus 5, a binomial, raised to the 12th. I'm not going to actually multiply that out, but 3x plus 5 raised to the 12th, and I ask you to please express that with the help of the binomial theorem. Just express it for me, see what it looks like. Like a summation. Now, how would you get to start? Let's say the exam is going to just ask you to express it using the binomial theorem. Yes, go for it.
Sigma, 12 on top, and j equals 1. Or
0. Oh, so 0.
Start with 0.
Yeah, you got to start with 0 on the binomial theorem. Those summation formulas must start with a 1. This is binomial theorem. And what's inside?
3x.
Well, something else.
Oh, should I put 3 out in front?
Yeah, I could put something else.
I would put just 3x.
That's going to be in there. That's going to be in there, but I need something, whatever the coefficient.
Oh, you want 12 over.
Yeah, 12 over what? J?
Got excited.
Now, finish it up.
3x, 12 minus j.
You got it?
And then it would be 15
All right, put a 15 in there, okay.
in parentheses, and then j.
That's what, guys? I may have said 3x plus 5, put a 15 in there. But we have set up, that's the way it looks with binomial theorem from yesterday. And then if I gave you reasonable numbers, I've got crazy numbers going on here, I could ask you maybe now express for me at least the first 3 terms. Let J be 0, let J be 1, let J be 2, and show me what, at least the first maybe 3 terms of these 13 terms. Is it 13 terms, I guess? 0 through 12. 13 terms in that, yeah, right here. In that expansion, should we have 13 terms? I may ask you, since you have it set up now and using binomial theorem, go ahead and actually expand it out and show me what the first 3 terms would really look like. It may take a little time to do that. Jonathan, thank you. That's the way it looks with the help of the binomial theorem. Okay, let's sit back and look at it, see if that's enough there to answer that. I think it is. And, okay, Caroline, this is for you. Letter D. A little recap. Of this chapter 11. I'd like to express and actually find the sum. I'm going to start with k is equal to 1. It looks like I went through 10. this expression. Now this one can get a little tricky. You've got to know your formulas. That's what Caroline was asking me about. So guys, this is not binomial theorem. This is using summation formulas. First, we're gonna split this up, like we did yesterday. As I split this up, we got summation, gotta start with 1 through 10 of k squared. Subtract, I am gonna place that 2 out front, which we're allowed to do through a property, and have merely summation of k, 1 through 10, and on the end, summation k is equal to 1 through 10 of merely 4. Did you guys agree, did I split that up correctly? Is that true? Did I split that up correctly? Now, Caroline and class, you've got to know your formulas. So the summation of k squared, that one has a strange formula. I think, remind me, it's n, I think n plus 1, was it?
2n plus 1.
2n plus 1 all over. And you're talking about a strange one, that's it. That's for k squared. So I'll go ahead and use that blue formula, calculate this, and I may get out of hand with these numbers. I see a 10 times 11. I guess I think down here, guys, what is that, 21? All over 6, and that's getting messy already. We'd have to crunch that out and see what that number is. Now it's gone down to the next term there. Just you have to crunch and get an answer there. The next one says I gotta subtract 2 outside. Now I need, for this one, a formula for summation of k. And that formula was, I think this sort of comes from what Mr. Gauss did. What was it, guys? N times,
N plus 1.
that's the easiest one, all over 2. And in my case, that would be 10 times 11 over 2. Now if you had to crunch that out, that's much easier, that's 55. That's no problem. On the end, which is the easiest one of all, if you just have a constant, I think the formula was what? Just multiply these two together, n times c, or c times n. So in this case, this last one here is merely, what's that, 40? That's n times c by formula. And of course, you have to crunch this out and put all that together. That stuff's just arithmetic. Okay, Caroline, to make sure we know our formulas, the one for k squared, k, and for constant to work with. Okay? Okay. Guys, we'll check. Let's see. I'm more interested in the reviewing today. Let's see what else I got here to discuss here. Oh, I do have another one before I close down. Okay, if anyone gets the final answer on this, if you play around with it, I know how the students are in here, they'd like to go ahead and get a complete answer. You can let us know what that answer was. Okay, next one. Looks like this. Oh, I like this one. If the sum is written like this. I think I have a 41 on the end. Step back, beautiful. And I ask you to find the sum of this. And you know you don't have the time to sit there, just add up 2 plus 5 and get a 7, 7 plus 8 is 15, then try to determine what the next term is, and add them all up, all the way through 41 and get a grand sum. You're not gonna have the time. So what am I gonna do first? I'm gonna ask you to please rewrite that using sigma. So all this, guys, I need some help. Can be expressed as in sigma notation, and I am going to start with 1. This is where I need someone to take a look at, and this can be tough. The term's given, and I need a formula. Jonathan thinks he has it already. Hang on. Anyone else think they have it? Ray, you think you have it? Now, one thing I did notice here, before the formula is announced to us, they differ by 3. So somehow that 3 must be playing a part here. Everyone have it, besides John? John, what'd you get?
3n minus 1.
Okay, or 3K. 3K minus 1, absolutely. Now, the only thing missing is the stopping place up here at the top. Well, since he's given the formula to me, 3K minus 1, and my last term is 41, why not go down to where that last term is, and with Jonathan's help, set 3K minus 1 equals 41, and see what K is. If I solve this, I think you end up with 3K is equal to what, 42? And K is equal to, if there's no mistake here, 14. Therefore, now I know the top number is 14. If all that's correct. Beautiful. So guys, for goodness sakes, you don't have the time to go directly across and try to add these up. Don't do that. I'm actually putting in sigma notation and then use the formulas to find the answer, the final answer. Now, since it's in sigma notation, I can now apply the formulas. I am going to split this up and place the 3 out front. We got sigma, going from 1 through 14 of K, then subtract sigma 1 through 14 of 1. And then to finish this up, this is 3 times. Now, Caroline, we're back to formulas. I need the formula for summation of just K, and that's the n times n plus 1 over 2. So in this case, that would be 14 times 15 all over 2. On the end, a little bit easier, since I have a constant there, merely multiply n times c, or multiply these two together, and you go into 14. Guys, make sense? Are we doing this by sigma, the formulas? Clean this up a little bit. I am going to try to finish this one up. I can do a little canceling. That's what, 7? Guys, inside there is 7 times 15 was 105, and 3 on the outside, 3 times 105. Is that 315? I did it quickly. That's 315. Subtract 14. I think it's what, 301? For a final answer? If you have enough energy left after the final exam, you think you're finished, you could go back and say, well, Professor, I got a little time before I turn my paper in. Let me just add these up. Just go ahead and add them all the way up through 41. Just see if I get that. Okay. Guys, that's what I thought of after class. Driving home, I thought, wow, we did so much yesterday. And this is all in chapter 11. Thank goodness chapter 11 is finished. It's done. I hope this helps some. Did it? A little recap, sequences, summations, N choose J, all that business. Okay. Stepping back and look at it, and someone walking in could tell, definitely this is a math class. This is definitely a math class. All these symbols I see here. Okay, guys, any concerns here before I erase? Anything at all? Now, a couple of my students were asking, Professor, how much more? How much more is there to do in this class? Are we finished yet? And I told you I'm doing a complete course. Same course I do in the regular semesters. I did this. Try to find where I am. Yes, right here. Guys, I'm not going to do as much as I usually do on this last part of the course. And that is this. Introduce what's going on here. We'll finish, at least finish the course out. Okay, part 1. The syllabus is asking us to do this. I said, where did this syllabus come from, Ramsey? It came from the math department. We all met together. We all decided which topics we are supposed to cover here. Chapter 9, brief, has something that concerns comics. This is sections of a cone. I did not bring the cone in with me to show you how to take a cone. We know what a cone looks like. And then they slice it into different sections and then give a name for each one of these sections. Guys, I just want you to identify the name and what equation is connected to that came from a slice of the cone. I did this, and I think I'm ready for it. I am. Hang on, because I think I have a handout. Goes along with this. What I do. Okay, guys, I'm staring at it. I need the copies for you. Here they are. Chapter 9 will be brief. Someone check. Never passed out to you. Is there a handout labeled sections 11.1, 11.2, 11.3? You guys are trying to keep your handout in order there. Where it says at the top, sequences and series. At the very top says sections 11.1, 11.2, 11.3. Let's check and see if you did receive one like that. So maybe I've already passed that out. If not, we'll find it. So it looks like this, if you want looking at it. So it looks like that. At the top there's sections, sequences and series. You got separate, 11.1, but you get, this one says sections 11.1, 11.2, 11.3. Nope. Did you not, you get that one? Okay, okay, then that's the one that's missing then. Hang on, hang on. Bear with me, more than likely I did not put it all together here. Mr. Park,